about a process within data analytics and data science known as the KDD process. Now, what is a KDD process? KDD process is known as the knowledge discovery in database. It's a process that's used by a lot of business analysts, a lot of analysts, and a lot of data scientists to work on end-to-end machine learning problems. Now, the knowledge discovery database has 7 distinct steps within it, and today we'll be discussing about those 7 steps. And this video is just going to introduce those 7 steps of the KDD process, and what I'll do is create 7 following videos which will go in detail about the KDD process, and we can go on from there. So, the first step in the KDD process is known as business understanding or domain knowledge. Now, what do I mean by business understanding? Now, let me give you an example. Let's say you're working for a platform. Let's say you're working for a platform something similar to Netflix. Okay. Now, let's say you are given a problem statement where they have a recommendation system, and they have asked you to optimize this recommendation system in a way so that you can reduce the error rate by um, by 1%, and you can increase the accuracy by at least 5%. Now, before you even think about lowering the error rate or the accuracy, or the modeling aspect of it, it is very important that you understand what recommendation systems are. Now, this is what understanding, business research, domain knowledge is all about. So before you can get your hands dirty in this area, it is very important for you to understand that what is recommendation system, how they work, and the maths behind the recommendation system. So you need to basically get yourself familiarized with how recommendation systems really work, and this is what the first step of the KDD process really deals with. It deals with business understanding, it deals with domain knowledge, and this is just a basic example of an e-commerce platform that recommends movies, or it's a movie platform. There can be various other industries, like say insurance, or let's say you have finance, or let's say banking, or you have retail. So there are different industries where data scientists or data analysts or business analysts usually work, and this is very important to understand that before you jump onto any new project, it is very important to get some sort of a business understanding or understanding of how that specific industry functions. So what usually happens is that a lot of people would spend times with domain experts who work in that specific industry to understand more about that industry. So this is just a brief overview of what the first step really talks about: the business understanding and the domain knowledge. Now, the second step that we're going to talk about right now is known as the data collection or data gathering. They're basically the same thing. This is you going out and actually getting the data so that you can work on it. So um, as you guys are data analyst or scientists, understand that 90 to 95% of the time you're working with data. So it is very important that you have data. This is where you start any sort of a machine learning problem. You need data so you can analyze it and you can work with it. Now there are different ways to collect data. So let's say you are working for Netflix. So how do you acquire data? You can get it from company. The company can provide you with data, um, or you can use APIs. Now APIs are basically known as your application uh, process interface. Now what exactly is an API? Let me explain this to you in a form of an example. Now let's consider Twitter. Okay, and let's consider this as me. Now if I want to get data, or if I want to get tweets from Twitter, there are a couple of ways I can do that. The first, very old school way, is to do web scraping, where I can write a few lines of code and I can get data from Twitter. Now another way to do this is to have an API. Now who really creates these API? It's the company itself. And why they create these APIs is so that they can give data out, to companies to work with, or to consulting firms, or any partnerships that they have. So basically they can sell data in a form of an API, and at times they charge a certain amount for this data, or sometimes it can be free. It depends what type of data source you're using, or what type of company you're collecting the data from. So this is data collection. This is the second step of the KDD process. Now the third step of the KDD process is known as data cleaning. Now once we get the data from the data collection, that data can be in a form of a CSV file, or a text file, or um, or let's say a PDF, whatever it is. Our job as data analyst or data scientist is to figure out a way to compile all these data and make one data frame from it. Now once we have that data frame, where we have compiled all our files together, we need to start cleaning that data. Now when we get data from different sources, there's a lot of noise in the data. Now what does noise basically means? Noise basically in a data means that there is a lot of irrelevant information in that data that plays no role when we use it for modeling. So what we need to do is we need to eliminate that noise from our data set. Now this noise can be in the form of um, NA, which is also known as your null values. Now a lot of time in your data sets you would have null values which have no predicting power, and would add no value when you're making any sort of machine learning models from it. So what we need to do is we need to omit these null values from the data set, so we can clean the data that way. Now there are instances where you know we would not remove the null values. For example, let's say if you're working with a monthly sales data, and one of the months have 0 as a sales, that means no sales was made. Now we cannot consider this as a null value, because 0 was a number that was actually inputted for that specific month. So I'm going to talk about this in detail, and I'll make a separate video on data cleaning, but just so that you have an understanding, that one form of noise in your data is null values. So we need to work with null values. We need to omit null values from our data set. Another type of noise that you may find, another type of data cleaning that you may want to do with your data is known as anomaly detection. Now what do I mean by anomaly detection? Basically what you're doing is that you're looking for any outliers in the data set, and if there are any outliers, you remove them from the data set, because if we have outliers, the modeling may not show fair results. Now this could be in the case, if you're running a logistic um, regression, and if you do keep outliers, then it may create a problem. But if you're working with decision trees, um, then having outliers really doesn't matter, because decision trees work in a different decision tree algorithm works in a different form compared to a logistic regression one. So you remove the outliers from the data set. Now obviously, in my next video or my other videos, I'll be talking about cases where we are allowed to keep outliers and cases where we need to remove the outliers. So when you're cleaning the data, you should remove any null values, look for any outliers. Then another thing you need to look for is sampling. Now this usually happens with your target variable. Now your target variable is nothing but the variable you're trying to predict. For example, let's say we're working with the cancer data. Now what we're trying to predict is that whether a person with sorry we're trying to predict whether a person has cancer. Sorry, I don't know what's happening. Whether a person has cancer, yes or no. So this yes or no is basically your target variable, and because we're trying to predict whether a person has cancer or not. Now what usually happens in such data sets is that the data would be highly imbalanced. Now what does imbalanced data mean? Now imbalanced data means that um, in a data in the data, you would have a lot of people who would not have cancer, but there will be a few percentage of people who would have cancer. Let's say 95% of the people in the data set don't have cancer and 5% of the people do have cancer. So this type of data is it's highly imbalanced data. So guys, just give me 1 second, I need to plug my charger in. Okay, sorry guys. Okay, I think this should be fine. Yep, perfect. So this type of data is highly imbalanced data, and we cannot work with this type of data because let's say we go ahead and we make a model based on the data I have described above. Let's say we create a model. Then this model 95% would predict that a person does not have cancer, and this is not a true indication of it, because we wanted data which is split in a way so that our model could not have any sort of bias. This 95% would create a bias in our model, and we need to eliminate that bias. Now how can we eliminate such type of biases in our model? We can do two things. We can do oversampling, or we can do undersampling. So what does oversampling means? Oversampling means that we are just increasing our yes. So we would increase our yes in a way so that our data would be split in, let's say 80% 20%, where 80% of the data would be no and 20% of the data would be yes. So this is a fair split that we can work with when we are modeling. And undersampling means that we can reduce, don't know what's happening with my pen. Okay, we can reduce the number of no's. So in this case, what would happen, from 95% we can cut this down to, let's say again we can do a 80-20 split, and we can see how well the data would or how well our model actually performs when we are doing undersampling or oversampling. Now there are different techniques that I can talk about in the later videos of how you can actually oversample or undersample the data. What are the advantages or disadvantages of oversampling or undersampling? I'll cover this in the later videos. But sampling is something that it's very common when you're dealing with data within the healthcare industry, or with when you're dealing with fraud detection, or credit card defaults, or insurance industries. So these are example of few industries where you may find a very highly imbalanced data set. Now, once we have covered once you have done all these, and we have cleaned our data, the next step in the KDD process is your data pre-processing. Now, what do I mean by data pre-processing? So we have taken the clean data, and now we would pre-process it. Now, pre-process data basically means you're working with two elements here. So the first element of data pre-processing is known as um, feature construction, and the second element is known as um feature extraction. Now, what does feature construction mean? Now, feature construction means that, let's say we have a data set, okay, with various rows, whatever it is, okay. Let's say we have month 1, month 2, and month 3. Consider this as your sales data. Now we have a sales data for 3 months. Now, how can we create another variable which could give a better indication of maybe these three variables? So what we can do, maybe we can create a variable that can calculate the average of 3 months sales. Let's say if we have a data for 1 year, then we can have uh, 4 quarterly datas, and then we can plot it, and we can visualize, on average which month or which quarter perform better. So this is basically on a very basic level of what feature construction. Basically, you're basically doing some sort of aggregations with feature constructions, or you're creating a new field based on the domain knowledge that you have acquired, or if you have any knowledge of the industry, you can create a new variable out of it. So this is one way to look at feature construction. Now, the second thing we look at is your feature extraction. Now, let's say I have variable 1, variable 2, variable 3, dot dot dot, variable n. Let's say I have n variables in a data set. Consider this, let's say I have 100 variables. Okay, now I cannot model all those 100 variables in the data set. Well, I can, if depending on what type of an algorithm I'm using. Let's say if I'm using decision tree, then I can void this entire step at all. But let's say if I'm not using decision trees, let's say if I'm using logistic regression, or support vector machine, or neural networks. So how would I go about selecting variables from the data set, or how would I find out that which variables would be important for my modeling? Now, there are different techniques that we can use to select the best variables for our models. Now, the first one is known as your Parsons correlation. What you can do is basically create some sort of a matrix, a correlation matrix, and you can find out which values are highly correlated, and pick those variables for modeling. However, when we are dealing with Parsons correlation, there may be a possibility of multicollinearity. um, Multicollinearity, I will discuss and talk about what multicollinearity is in my other videos, but just to give you an idea that multicollinearity might exist when we are running correlation tests. Another thing you can do is run Baruta, or you can run an AIC test, or a BIC test. Now, there are different approaches that you can use to actually figure out which variable works best for you. This was just a brief introduction. You don't need to learn all these. It's just a brief introduction, so that you know that these steps could be taken within the KDD process, basically within like the subcategories of it. So now that I've spoken about your data pre-processing, let's let's go on and talk about the fourth step in the KDD process. Now this is a step known as your data modeling. Now this is where we actually take the clean and the pre-processed data and we model it, and we model this data. So your modeling is nothing but you're taking the clean and the pre-processed data, you combine everything together and you just model the data. Now when you're modeling the data, you need to consider a lot of things. You need to understand what type of algorithms you would use. Now different type of business problems involve different types of algorithms that could be implemented or could be used. You need to understand whether the problem statement that you're working with, is it a supervised um, machine learning problem or an unsupervised machine learning problem. You need to understand that as well. Moreover, when you're selecting algorithms, you need to see how the data is split. You can construct a pair plot and you can see how your data is split, how well it is split, so you can understand what type of an algorithm to use based on the way your data is actually split. Now when it comes to your actual algorithms, now there are a wide range of algorithms that you could use when it comes to data modeling. You've got your support vector machine, you've got your neural networks, you've got your decision trees, you've got your logistic regression, you've got your lasso regression I think you can use for your what's this called, you can use this, sorry, your lasso regression you can use for selecting your variables as well. Rigid regression or lasso regression, you can use that there as well. If I'm correct, I would need to double check that, but as far as I think you can. But yeah, you can do logistic regression, decision tree, neural network, and there's a lot of other algorithms that you can also use when constructing the model. Now once you have created the model, the next step, number 6, is to evaluate the models. Now let's say you have a model of support vector machine and neural networks. Okay, and you're sitting in front of the management and you need to tell them that I'm going to be, or you need to propose a model that they can implement for their company. Now how would you decide which model is better, either the SVM or the neural network? Now this is where your evaluation metrics come into picture. Now your evaluation metrics, so what you do in this step is that you have different types of evaluation metrics that you can use. Now let's say we have your confusion matrix. Let's say then we can look at the precision, we can look at recall, we can look at a model sensitivity, um, we can look at a model accuracy, how accurately is a model able to predict. Then we can look at our root mean square error, we can look at a mean absolute error, what type of error rates are this, is this model producing, we can evaluate that as well. And once we have decided, then we can select, okay, let's say the SVM model performs better because it has a better accuracy, error rates are low, the confusion matrix shows that it's not highly sensitive, so that's why we should go with the support vector machine. Now this is how you evaluate a model, so you can calculate all these to actually evaluate which model is performing better or not. And lastly, once we have decided which model to choose, we need to understand and we need to know how to deploy the model. Now model is very good until it's on your computer or on your system, but it's adding no values. What we need to do is we need to actually deploy this model. You can use AWS, you can use Heroku for model deployment. And what model deployment actually means is that, let's say I have a web application. Okay, let's say I have a web application, whatever it is, and there I can actually integrate my machine learning model, where it would help me make predictions, or it would help me optimize something, or whatever the problem statement could be. So it's very important that you deploy the model, and after you've deployed the model, we can perform A/B testing, or we can perform various sort of analysis which would further create like a shield on a model, and show us how it performs in different sort of sandbox environments. um, so yeah, that's to do with the model deployment, and this is the final step of the KDD process. So what I'll do now is that I will um, just do a summary, and I'll write all the steps down. So this first step was the business understanding. The second step was data gathering. The third step was data cleaning. Fourth step was data pre-processing. Fifth step was data modeling. Sixth was your model evaluation. And your final step was your model deployment. Now, you are a data analyst, data scientist, business analyst. You need to understand the KDD process by heart. I mean, this is what you're going to be doing mostly on a day-to-day basis, or on a project-to-project basis. If you are a business analyst, I can understand that you would not be spending so much time on model deployment. But if you're a data scientist, you would be spending a lot of time here. Then obviously maintaining this particular model when you deploy it. Um, in terms of data gathering, you would, as a data scientist, you would need to manage the data warehouse, data lakes, create SQLs. So the data science, I think, would have a more heavy back end to mid office kind of roles, whereas a data analyst would be also performing something similar, but would not be working so much on a model deployment, because as data analysts, this is something the course doesn't really teach. But as a business analyst, I feel that you would need to at least understand up to the model evaluation part, know how to actually evaluate a model. If you're given two models, which model performs better, why it performs better, you should know all the answers to that, because as business analyst, you would be the type of people who would be interacting a lot with clients. You would be interacting with the CEOs, company management, the management, the higher management. So you need to convey your insights, your models in a way so that they can understand. Because you cannot go to a management and say that the neural network has a 10% lower error rate. Like, they don't really care about it. No, you need to translate in a way or in a language that they understand. So that's why business analysts actually exist, because you act as the middleman between understanding what data is and then converting it into a language that managers and higher authorities, or CEOs, can understand. So you need to start building that conversation of how you can translate um, a given model in a way that higher management can understand. So yeah, so this was the first video where we have covered the KDD process. What I'll do is, these notes that I've made, I will create some sort of a Dropbox link or a Google Drive link where I can share these notes with you, and you can have access to this. And Apart from this, if you guys have any questions, just leave them down in the comment section below, or I'll also drop my LinkedIn ID below. So if you have any questions, just drop me a message on LinkedIn, and we can definitely have a chat about it, and I can help you out. The next following videos would focus more on the individual KDD steps. I'll go into further detail as to what each step really involves, and how we can um, tackle those steps, and how we can actually execute everything in a structured manner. So I hope this first video was a value add to everyone who is watching. Thank you if you stayed till the end. Thank you so much for being a part of it, and I wish you luck. And till my next video, keep learning.